All righty then. Okay, so I would like to see, so we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. All right, we got everybody who normally comes here. That's good. Okay, so we're gonna start on the law of cosines. Okay. So these are used for side, 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 or side, angle, side triangles, okay? So basically, the idea here is c squared equals a squared plus b squared minus 2ab cosine c. Or a squared equals b squared plus c squared plus minus 2bc cosine a, and b squared equals a squared plus c squared minus 2ac cosine b. So the idea here is you've got the two sides minus the 2 times those, and then the cosine that's in between. So if you got a and b, you've got the cosine of the angle in between, and it works with any things. So these three here are your law of cosines. So solve triangle ABC and so I've got the triangle here already drawn. If B is 110, A is 10, and C is 15, excuse me, find B. Now, who did we ask yesterday? I don't know. We're just going to start at the top today. We're going to go with Brian Larson. So Brian, can you help me solve this triangle with the law of cosines? Which one of these three are we going to want to use?
I guess that's a good question. So, B equals 110.
And here's your triangle right here.
Okay. So I guess if we're looking for B, it would be the third one, right?
Yeah, that's exactly right. So we're going to use this one right here. I don't want to copy that triangle. I just want to copy the formula. Okay, so let's substitute in. So what's A in this case?
A would be 10.
So 10 squared plus C, which is
15.
15 squared minus 2 times
10.
10
is 15
times 15 cosine
of 110.
110. Okay, so this is pretty easy, right?
So far.
So far, if we do that, we should get B equals 20.7 centimeters. Now, do I need to show everybody how to do that, or do you all believe me? You can plug this in your calculator, right? Hopefully. Anybody scared?
I think it might be helpful for me. I mean, okay. It's pretty basic, but I think it'd be solidifying.
Okay, so I thought I copied that. Okay, so 10 squared, 15 squared, minus 2 times 10 times 15, yeah. Now, in my case, my calculator is in radians, so I need to convert this to pi over 180. But you guys should be able to, if you set your calculator right, you should be able to get that. But it should be, what did I forget? Oh, it doesn't like this minus sign. Yeah, that's right. Isn't that what I typed? 10 squared plus 15 squared minus 2 times 10 times 15 times the cosine of pi over 180. Why isn't that doing that? That should be 20.7. Do I not need to worry about this? I could have sworn I do.
That's the same answer I got when my calculator's in degrees.
Isn't it the square root of all of that?
Yeah, that's right. I forgot about that. It's plus the square root of that. Yeah, there we go. 20.7, just like I said. Because remember that is b squared. B squared. So we can take the square root. Okay? All right. Guess it was a good thing I did that. Okay, how about this one? Solve triangle ABC. We want to find angle B in this case. So since Brian did that one, it must be Brody's turn.
Brian, I have a quick question.
You guys are my two guys that don't like to be on camera, right? Sorry, who had the question? I didn't hear that. I heard the question. I don't know who said it.
Yeah, that was Mason.
Mason.
So if you go back to the notes real quick. So on the last one we just did, would we have to find the angles too using the same law of cosines?
Oh, well, that's what we're going to do next.
Oh, okay. I got you.
So yeah, that was the next one. So so Mason and Brody, you guys can tag team on this one. How's that?
Sounds good to me.
So if I give you all three sides, can you give me the angle?
Yeah, I should be able to.
Okay.
So we want to use the same, the third one.
Same formula. Okay.
Yep.
Okay, so let's use the same formula. Okay. Except for obviously I copied the wrong thing, but that's all right. Okay, so so this is b squared. You know, let me just copy this thing. I'll copy it right this time. I have two laptops and the control key is in a different spot. And it drives me crazy. So when I switch between them, the two, that worked that time. Okay, so
then we just plug everything in, and so it'd be 20 squared is equal to 32 squared plus 40 squared minus 2 times 32 times 40. And then you'd take the cosine of B, and then we'd solve for B.
Okay, so B is going to equal 20 squared divided by, well, I guess maybe we should do the math. I was going to think I could do that in one step, but I better not. Okay. So I'm just going to leave this as 20 squared. Well, 20 squared is 400. I can do that one in my head. The other ones I'm not so sure about. I need to subtract 32 squared and subtract 40 squared, which is 1600, right?
Mm-hmm.
That's going to equal 2 times, I can't do that in my head, 32 times 40, cosine of B. Okay, and then what?
Then we'd want to just solve the number to the left, and then we could divide it, right?
Yeah, so I've just got the cosine of B is going to equal all of this, whatever that is, some big number.
I didn't follow why it's plus 1600.
Well, I've got, oh, it is, you're right. It's supposed to be a subtract. Thank you.
And then where did our negative go in front of our 2?
Oh, you're catching all my mistakes there. Good job. Okay. All right. So then all of this is going to be divided by the -2, right? All this here. Okay. So if I type that in to my calculator here, except for it doesn't like these dashes, and I should put a parenthesis here. 400 minus 32 squared minus 1600 divided by -2 times that, all that. Okay. So that's 0.86875. Okay. And then I'm going to do arc cosine of this. Of course, that's in radians. So now I need to convert that back to degrees. So that's this number times 180 over, well, I guess I don't have to. I could leave that in radians, but I like to think in degrees. And that's going to be a 29.5 degree angle. Does that make sense?
Yep.
Okay. And I rounded it to 30 in my notes, so I almost 30 degrees. Okay. All right. This isn't too bad. You guys liking the law of sines and law of cosines so far? All right. Now we've got another one of our awesome problems here with bearings and headings. Okay, so a boat sailed 3 miles at a heading of 78 degrees and then turned to a heading of 138 degrees and sailed another 4.3 miles. Find the distance and bearing of the boat from the starting point. I'm going to make this a little bit bigger so that we can see it better. Okay. So we started at point A, we sailed at a heading of 78 degrees. So we're 78 degrees here, sailed for 3 miles, and then turned to 138 degrees. Okay. So we're going down here and sailed another 4.3 miles. Find the distance and bearing of the boat from the starting point. Okay. So we're changing from headings to bearings. Okay. Because we love to do that. So how would we do this? I'm going to throw this one out to anybody because this is a fun problem. Now, I guess I should also point out here, remember that this 78 degrees here is the same as this 78 degrees here. So we should be able to find out this angle here. So what is this piece right here that's not labeled?
42 degrees?
42 degrees.
Yeah, because this adds up to 180, right? So 42 plus 78, what is this angle B going to be?
114.
Okay.
120.
120. Sorry. Yeah, my bad.
Yeah, so that's going to be 120. So I think, yeah, there we go.
I mistyped.
Okay, so angle B is going to be 120 degrees. Okay, so that's really nice. So we've got a side, we've got an angle, and we've got a side. So what are we going to use to do this one?
Just a random guess. Maybe the law of cosines?
What a wonderful guess, right? Imagine
B squared equals A squared plus C squared minus 2 times A times C cosine of B.
Perfect. Okay. So
I
that's
recited that
exactly
from
right.
memory.
You did that from memory?
Yeah, just from memory.
Well, that's pretty good. Yeah, so we're going to use this one here, B squared, okay? So A squared plus C squared plus 2AB. Okay, so what can we...
Isn't it 2AC cosine B? Not 2AB cosine B?
Right.
You're right. That's supposed to be a C. You've caught my notes. Okay. Yeah. So we're going to use A and C because we've got those, and then we've got the angle in between. Okay. All right. So how do we find side B here? So we're just going to plug in. So what's the A going to be in this case?
That will be
4.3.
0.3, and the C will be
3.
3. So then this is going to be 4.3 times 3. And your cosine of B is
120.
120. Boom. Okay. So then when you take your square root of all that, you're going to get 6.36 miles. Okay. So we know that this side is 6.36 miles away. So from the starting point. Now, the next question is, how do we find the bearing?
Couldn't we just do a another one of these law of cosines to find the angle of C?
All right. Or A. Well, we can, let's see. The cosine of A is going to be, so we could find it for the cosine of A. So we could use that formula there. So that'll give us this angle here. And we know that all three of these angles have to add up to 180, right?
Right.
So what I've done is I've just taken this formula right here, this middle formula, and I've solved it for the cosine of A. So the cosine of A is going to be B squared minus C squared, B squared plus C squared minus A squared, all divided by 2BC. And so since we now, I don't know why I did that. I probably should have left that at 6.36. In fact, I think I'm going to, so that I'm a little bit more accurate. So your A is going to be about 35 degrees. And that's this right here, this piece right here in the middle. It's not marked, okay? And so to get the bearing, so you're going to be about 6.4 miles at a bearing of south 67 degrees east, because 78 plus 35 is whatever that number is. So 180 minus that is your 67 degrees. And so this alpha right here is your 67 degrees. So you're going to be south 67 degrees east from the starting point. Or from the end point, you could also, because if I draw my north-south line right here, then we could do it from that, and you're north 67 degrees west. Okay? Does that make sense?
Yeah.
All right, so in summary, just to make sure we know, okay, we're going to use the law of sines if we have angle, side, angle, 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 side, or side, side, angle, okay? So angle, side, angle is the measure of the two angles of the triangle and the length of the side of the included side. Angle, angle, side is going to be the measure of two angles and the side opposite one of those angles. And then side, side, angle is the length of two sides of the triangle and the measure of an angle opposite those two sides are known. This is called the ambiguous case, and it may yield one solution, two solutions, or no solutions, okay? So as we're looking at our triangles, this is going to be important to remember. So angle, side, angle, 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 side, 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 angle is all law of sines. And just remember with side, side, angle, you got to be careful, basically, because you could get 0, 1, or 2 solutions. And then with the law of cosines, So this is going to be an oblique triangle. So you can use law of cosines for side, 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 or side, angle, side. So length of all three sides are known. After finding the measure of the angle, you can complete your solution using the law of sines. So if you have side, 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 you'll start with law of cosines, and then you can switch to law of sines to find everything else. With side, angle, side, the length of the two sides of the triangle and the measure of the included angle are known. After finding the measure of the third side, you can complete using the law of sines. So we really like the law of sines because even when we use law of cosines, we're probably going to go back to law of sines. So any questions on this so far?
Nope.
Okay. All right. So now let's move on to, we're going to use the law of cosines to find area. Okay, so in the book, they call area K because usually when we're talking about normally you'd say A for area, but we're using ABC for our triangles a lot. So the area of a triangle, hopefully we all remember that it's 1/2 the base times the height. So the height of a triangle can be calculated as the height equals C times the side of A, times the sine of A, okay? So if we're looking here, your height is C times the sine of this A, okay? So we can substitute that in here. So the area of a triangle is going to be 1/2 B times C times the sine of A. So we can do that for any such angle. So the area of the triangle ABC is 1/2 the product of any two sides and the sine of the included angle, okay? So if you've got two sides and the included angle, you can find the area of a triangle, okay? And it doesn't matter whether it's an acute triangle or an obtuse triangle. Okay, so now find the area of a triangle. Oh, I didn't put that there, but if A, okay, so it's this one right here. So A is 62, B is 12 meters, and C is 5 meters. So I'm trying to remember, I think it seems like Brody got off the hook, right? Brody, can you help me find this area here? And I've got all three of these here, so you can pick any one of those three that you think will be useful.
He said that he was having trouble with his mic in the conversation or in the.
He did? I didn't hear that.
No, you're okay.
Okay, thanks for letting me know because I didn't see that. Okay, so let's go with Cameron Daly. Where's Cameron? Oh, there. No, that's Cameron Robert.
I'm here.
Okay. So which of those three formulas would you like to use?
The first one.
Okay.
So let's see. So we do K equals 1/2 12 times 5 times sine of 62 degrees.
Okay. Should we type that in just to make sure you've got it down?
Yeah.
Okay, so I'm going to change this to 0.5. I'll get rid of my K. I will multiply that times 12 times 5, and the sine of A was 62. Except for in my case, I've got to convert it back to radians. How do you do that again?
Pi over 180.
Over 180. Why didn't that work?
You didn't put a multiplying symbol between the 5 and sine?
Oh, there we go. That's why.
That's interesting.
Is it because I put a space there?
I think you need one more close parenthesis.
It's reading in this text for some reason. There we go. That worked that time. I had a space in there. So 26.488. Okay. And so this would be, well, we don't have any units on there, but if that was inches or whatever, it would be inches. Okay, so 26 square meters. Okay. All right, so now we can also use the law of sines to find the area, because remember that b over the sine of b equals c over the sine of c. We could solve for c, and so c is going to equal b times the sine of c over the sine of b. And so now we can plug this into our formula, because it wasn't complicated enough, remember. So k equals 1/2 your base times your height. So we can substitute that in for b. So 1/2 b times b sine c. So then you're going to get times the sine of a. So you're going to get this nice ugly formula, b squared sine c sine a all over 2 sine b. So the nice thing about that is, I guess that's useful if you have all of the angles and only one of the sides. And so you could do that for these other two formulas as well, okay? So given these two angles here, so you've got all three of these work here. So I've got two angles, and of course if I've got two angles, I've got three angles and one side. So find the area. So let's see. Of those three formulas, I'm going to put that there so you can see them all. Whose turn is it now? Cassie Gonzalez, I think it's your turn.
Okay.
Which of those three area formulas would you like to use? And you can say 1, 2, or 3.
Probably.
Probably which one?
Sorry, I'm just looking at it again. Probably the first one. No, the second one, sorry.
The second one. Yeah, we're going to use the second one because we know the side A right here, okay? And this one has the A squared in it, okay? So I'm going to copy that there, and then you can tell me what to fill in for everything, okay? So A squared is going to be what?
14 squared.
14 squared sine of B. B is the one angle we don't have. Here, we'll figure that one out in a minute. What's C?
77.
77. And A is?
32.
32. And how do we find B?
Minus, sorry, add 77 and 32 and then minus 180.
Okay, so 77 and 32 is 109. If we subtract that from 180 minus 109, we're going to get 180 minus 110 is 70, right? So that'd be 71. Yeah. 71. Okay, so I wonder if I can type this in here to my calculator. Oh, that actually worked pretty well. I need to put a multiply here and a multiply here. and a multiply here. Oh, except for I got to convert all these to degrees. What a pain in the butt. So 71 times, actually, can you help me with that?
Pi over 180.
Pi over 180. See, so you thought you could forget that formula clear back in chapter 2, what is it? All right, times pi over 180. Except for your calculator might do it. And then sine of 32 times pi over 180. 170.37. Okay, piece of cake.
Mm-hmm.
Do you like these? They're just plug it in, basically.
Yeah.
All right. So I guess I got that same thing twice in there. Okay, so now we're going to introduce you to Heron's formula. Okay. This is how you can find the area when you know all three sides. Okay. Now, the area, okay, equals S times S minus A, S minus B, and S minus C, where S equals 1/2 of the sum of your three sides. So 1/2 of the perimeter, so you can think of this as 1/2 of your perimeter. And so 1/2 of your perimeter in a triangle is called the semi-perimeter. And so, Cass, you did a great job there. Chris, how's your microphone today? Chris is usually on camera. Where are you, Chris? Oh, do we have a thing here? Where'd you go, Chris? We lost Chris. Okay, we're going to go to Corey then. Oh, he's got his hand raised. What does that mean? I don't know what hand raised means, Chris. I guess it means you can't talk. Corey, help us out.
Alrighty. So we're gonna figure out S first. So it's 1/2 of 7 plus 15 plus 12.
Since 22 plus 12 is 34, 1/2 of 34 equals 17. Okay.
So now we're gonna do K equals the square root of 17 time square root of 17 minus 17 minus 7, and then times by 17 minus 15 times by 17 minus 12.
Okay, so this is, so K is going to equal the square root.
Do we need 17 out front of all of those?
Mm-hmm.
Oh, you're right. I forgot the 17 out front. So 17 times
10
times
2 times 5.
Times 5.
Which
10 times 2 is 20, times 5 is 100, times 17 is 170.
Isn't that 1700?
20 times 5 is 100. Yeah, 1700. You're right.
Okay.
Square root of 1700, which, as everybody knows, is 41.23. I knew you guys all knew that in your head, right? 41 square meters. Okay. All right, piece of cake. You guys liking this? All right, I got a note here. Oh, sorry, Chris. I wish you had better internet. Thanks for letting us know. All right, so, all right, let's talk about the Luxor Hotel. You guys all remember the Luxor, right? Down in Las Vegas. Each face is an isosceles triangle with 646 feet and sides of 576 feet. Assume the glass is $35 per square feet. Find the cost of one of the triangular faces. So, let's see here. Graham, this looks like a good problem for you.
Okay. So both sides are 576 feet, right? And just the base is 646 feet?
Right.
Okay. So let's see. So it would be, so we'd have to find S first, right?
Mm-hmm.
And that's 1/2 of 576 plus 576 plus 646. Which I don't know off the top of my head, unfortunately.
Oh, come on.
Yeah, one day I'll get it.
So here, we'll do that one.
I got 899.
Oh, that didn't copy. Here, let's do it this way. I'm going to put a 0.5 in there. Equals 0.5 times all that. I got 899 too. Bang. So you're good there. Okay.
So then,
Okay.
let's see. We would do the square root of 899 times, in parentheses, 899 minus 576, in parentheses, 899 minus 576, in parentheses, 899 minus 646, right?
Yeah, is it okay if I put a times 2 there?
Yep.
Okay. 899 minus 646. Okay. So,
squared instead of times 2.
Oh, you're right. It is squared.
Hey, Aaron, I was just calling. I have a member who did a financing contract and then forgot to sign it, and now she's reviewing it and she has questions.
Well, somebody's working instead of paying attention to class.
Number is 404.
So that's 154,043 square feet. These are all in feet, right? Yes. Yes. Okay. So how much does that cost, Graham?
A lot.
A lot of money. How would we figure out the cost?
So you just multiply that number, which was, 154,043 times 35.
$35, and it's only, let's put that in dollar signs here.
$5.4 million.
$5.4 million per side. So that's times 4, right? 4 sides, because it's a 4-sided thing. Only $21 million. Yeah, it only asks for one side, but yeah. But you could multiply that by 4, and boom. That's a lot of stuff. All right. And then just for fun, this is good because I don't have the answer here. Solve triangle ABC if A equals 32 feet, B equals 20 feet, C equals 40 feet. Find angle B. Oh, did we already? I don't think. When did we? That's a good review if we did it already. Plus, I don't have the answer here. So, Jackson, can you do that one? This will be a good review.
Solve triangle ABC. Let me just draw this real quick.
Okay.
Okay, so we have 3 sides.
Okay. So
And
which
then
law are we going to use?
So we'll say c squared equals a squared plus b squared minus 2ab cosine of c.
Minus 2ab cosine of c. Okay. Then what? So we're using the law of cosines. I was hoping you'd say that, but anyway, yeah, law of cosines. So why is it law of cosines and not law of sines? Just a quick review.
Because we have 3 sides.
Because we got 3 sides. Okay.
So now we need to solve for cosine of c.
Okay.
So cosine of c will equal a squared plus b squared minus c squared divided by 2ac.
All over minus 2ab. Okay.
And now we can plug in some numbers.
Okay. What do you got?
So it would be 32 squared plus 20 squared minus 40 squared. And we'll divide that by 2 times 20 times 40.
Okay. Let's see how well this does, oh, except for it's not going to like my minus sign over here. So that's in radians. I guess that's okay. So then we're going to do arc cosine of that, which is 1.46. And then we're going to take that number times 180 divided by pi. Whoops. What did I do wrong? There we go, 83.68 degrees. Okay. All righty then. Well, we're getting done too early. What's wrong with you guys? Is it getting too easy? All right. Well, that's good. I think we started with Josue yesterday, so I think we missed Texas 2 days in a row, though. Texas, you're going to start us off tomorrow. Sorry, there was a question?
Yeah, so
Chris, maybe you should type your question because I can't tell what you said there. Corey left. What happened to Corey? He had to go to work early. Didn't we just find an angle C and not B? Oh, yeah, we did. All right. Well, anyway, we found angle C. We probably should have found angle B, but either way, it's the same process. I didn't even notice that. Yeah. All right. All right. Well, Jackson steered us the wrong way, but that's close enough. All right. Any other questions you guys have? Okay, then. Well, I'll let you go 10 minutes early again today. And homework is due on 4.2. And you guys will remember all these formulas for the test. Quick reminder, so we've got a test a week from Thursday and then a final 2 weeks from Thursday. So according to my schedule, I have a few days during finals week to review everything, so that will be good. So if there are no other questions, I guess you can stick around for Texas study group, and I'm going to start recording. So see you guys later.